Okay, and continuing with our final review, what we have here is a stoichiometry problem. So stuff that involves limiting reactant, theoretical yield, and percent yield all in one. And so we have an equation, it's not balanced. We need to balance this equation first. So we have two oxygens over here, we need two over here, so this is going to be 2. And now we have two magnesiums over here, and we need that to be 2 as well, and now this is balanced. And this is important because we're going to, as these react, we need 2 magnesiums for every oxygen that we use. Okay, and so it starts off with 5 grams of magnesium reacting with 12 grams of oxygen. When we're doing this, one of these is going to run out first. When that one does run out, our reaction is finished, and that is going to kind of max out how much magnesium oxide we can produce. So the theoretical amount of magnesium oxide we can produce is going to be limited by which one of these runs out. Okay, and the way I like to think about that, so if we were to fully react this 5 grams of magnesium, how much oxygen would we use up? How much would we need? And we compare it to what we actually have. So if we're comparing this stuff, what we really need to compare is moles. So moles are what really reacts. So we need to convert this to moles, where 1 mole of magnesium weighs 24.31 grams. Okay, and so we do that, the grams of magnesium cancels out, and this would tell us how many moles of magnesium we have. Well, to figure out how many moles of oxygen we have, we need to look at that balanced equation in our ratios. For every 2 moles of magnesium, we can get 1 mole of oxygen. We only need half as much oxygen as we do magnesium to get this to work. And you can see whatever we have on top unit-wise, that's what's going to be next on the bottom. So our moles of magnesium would cancel out. Okay, and so we'd have a certain amount of moles of oxygen. And we were trying to figure out mass in this case, so each mole of oxygen, O2, weighs 32 grams. Okay, and once we have this, what we do is we multiply everything on the top, divide by everything on the bottom. So you could do 5 divided by 24.31 divided by 2 times 32, and that tells us that we would need about 3.29 grams of oxygen to use up the 5 grams of magnesium. Well, we clearly have plenty of oxygen. We have 12 grams of oxygen, so magnesium is going to be our limiting reactant. And so magnesium is the number that we're going to start with to figure out how much magnesium oxide we can produce from this. Okay, so let's start again with 5 grams of magnesium. And we're going to be doing a similar thing here with magnesium and magnesium oxide. So again, we're concerned about how many moles of magnesium we have to be able to use the mole ratios. Okay, and our mole ratios here, so is for every 2 magnesium we get 2 magnesium oxide. It's exactly the same. It's going to be 1 to 1. So 1 mole of magnesium for every 1 mole of MgO. And then 1 mole of MgO weighs 40.31 grams. Okay, and so same thing where if we multiply what's on top, divide by what's on bottom, it would tell us that maximum we can get 8.29 grams of magnesium oxide from this. Okay, and so that is our theoretical yield. So this is our limiting reactant. 8.29 is our theoretical yield. We're given our actual yield. So our actual yield was 8 grams of magnesium. And so if 8 grams of magnesium is what we actually got, 8.29 is our theoretical, that percentage, 8 over 8.29, will be our percent yield. And if we do that, so that 8 divided by 8.29 times 100, we'd have 96.5% yield on this problem. Okay, and so what we're doing a lot, so grams to mole, mole ratios, moles back to grams will tell us a lot of different things, whether it's how much of the other reactant you need. If you have this reactant, have one reactant, how much product you can get. If you get a certain amount of product, how much of the other product you can get. All of which is going to be determined by this mole ratio, which is given in our balanced equation. So grams to mole ratios, moles back to grams will tell us a lot of things, and then there's just a little bit of interpretation that we need to do to figure out the rest.